Okay, so hopefully you got, maybe you figured your way through number 2 here. Let's go ahead and try it together. So, where, of course, you know how to start. You're going to start off with your statements, your reasons. Make sure you are numbering the each side. So first, I'm going to start off with my given. QT is congruent to RT, and TS is congruent to TP. And my reason, of course, is yes. All right. Let's see what we need to prove. They are asking me to show that all of QS is congruent to all of RP. So let's mark in the diagram what they've already given us. QT is the same as RT. So I'm allowed to mark those two as congruent. They also told me that TS is congruent to TP. So notice how I mark those differently. I don't know that TR and TP, for example, are equal to each other. So you don't want to mark them all with the same marking because it doesn't say that all 4 of them are equal to each other. I have one set of 2 and then another set of 2. So that's why I marked it with 1 slash and then 2 slashes. Okay. So do you buy that this whole thing would equal this whole thing? Yeah, it certainly seems reasonable, right? I have one, yeah, if these are the same and these are the same, if I add them together, I should get there. Now it's just a matter of, okay, I know how it's working in my brain. How am I going to put it down here on this 2-column proof? Anybody have an idea where I could start? Riley, go ahead.
Would you be able to do QT plus ST?
No, because their angles add up to be 180, but segments, we don't know, like the length of TS and the length of QT, we don't know what their lengths would add up to be. If you were talking about these angles in here, like this angle plus this angle equaling 180, that would work. But I don't think that's going to help us in this particular one. Does that make sense?
Yeah.
Ava.
Yeah. Will you do QT plus RT equals ST?
Hold on. QT plus what?
ST
Yes. Equals what?
PT plus RT.
Yes. I'm going to write it as RT plus TP if you don't mind. Same thing. And what was your reason for that?
Would be substitution.
No. So let's recap what she's done. Take a look at your very top line. You have QT and RT, one on each side. You still have that. You still have QT here. You still have RT over here. So what has happened? What has changed? I don't know why I just wrote with my pencil and messed up my brand new notebook. What was I thinking? Oh, golly. I write with a special pen and I wrote with pencils, silly goose. Anyway, so I still have QT and RT, one on each side. What else do I have? I've now added ST to one side and TP to the other. You've already said that those two things are equal to each other. So you've taken two things that are equal and you've just added them to both sides. So what is that? When you take the same thing, Elizabeth?
Is that the addition of the
Yeah.
inequality?
You got it. That's just addition. You took the same thing and added it to both sides of an equation. So that is the addition property of equality. By the way, see how that's TS and that's ST? That doesn't matter. That's no big deal. All right, where can I go from here, do you think? Aiden, you have a thought? Go ahead.
QT plus TS equals QS and PT plus TR equals PR, and that's segmentation part.
Yes. Great job. QT plus ST. Look at the diagram. Doesn't QT plus ST or TS, whatever, those two together, doesn't it equal the whole thing, QS? Elizabeth?
Could you flip around steps 2 and 3, or does it have to be in that order?
You could have flipped steps 2 and 3, yep, because they are independent of each other. So QT and ST is going to be QS when you put them together. And then you could do the same thing for the other diagonal. So the other diagonal, I've already got it here, RT plus TP together gets you PR. And that is segment addition. Oh, you know what? One other thing that I haven't mentioned to you yet. See how I have it lined up? Like, even though this side of line 1 took up 2 lines, when I put line 2 over here, it lines up with line 2. Don't like put it directly underneath. You know what I mean? Because then they're going to be like, they're not going to be right across from each other. You should be able to like draw a line, and you know what I mean? Otherwise it's going to get, I won't be able to follow you at all. It'll be all over the place. So just try and keep wherever you start a new line, that's the whole new thingamajiggy. All right, so segment addition, and we're almost there. Can I now say that QS is equal to PR or RP, whatever? What would my reason be? QS is congruent to RP. Why? Go ahead, Elizabeth.
Be the substitution.
And say substitution. If you said transitive, that's fine. But you really are doing one substitution step, right? You're really replacing this with a QS. You're really replacing this with a PR. So usually we use transitive when I'm doing multiple substitutions on the same thing. Like A was equal to B, but then B was equal to C, and then C was equal to D. So now I'm just going to say A is equal to D. I didn't really do that here. I just did one step. I just swapped on one side for one thing and I swapped on the other for one thing. And that's it. That's what I wanted to prove. So I'm done. Oh, wait, it was RP. I wrote RR. Silly goose. And there you have it. I'm going to try number 3 with you also. Let's see how that goes. So again, I'm going to have my statements and reasons. Line 1, ray BD bisects angle ABC. Given, of course it's given.
Isn't it a right?
Yes. So you have ray BD bisects angle ABC. My ultimate goal is to prove angles 3 and 4 are the same. All right, so let's kind of talk about this one. If I look at the diagram, I want to show that angles 3 and 4 are the same as each other. That's my end goal. All I have is that ray BD is bisecting angle ABC. Ooh, you know what? This one's not really, well, we talked about what will make this 10,000 times faster. And we talked about it, but I don't think we officially put it in our notes. That's okay. I'll do it with you now. And then you can use it for forever. Because it's going to be one of your favorite things to use all the time. Anyway, where can I start? If you have no idea where to start, here's a good tip. Look at what's given. If BD bisects angle ABC, well, what does that mean? What can I get from that? Carson, go ahead.
That angle 1 and angle 2 are equal.
Yes. Right? Angle 1 and angle 2 must be equal to each other. This ray is bisecting the big old angle. So let's go ahead and say in line 2, angle 1 is equal to angle 2. How did we know that? What was it that told us that that was going to be true? What was the giveaway? Yes, they used the word bisect. And you know what the word bisect means, don't you? Hopefully. It means take something and cut it into 2 equal parts. Literally, you're using the definition of bisect. That word bisect means something, and its meaning tells us that those 2 angles are going to be equal to each other. Okay, now we mentioned this. I don't know, we did something once. I remember doing it with you. And we talked about it, but it's not official in your notes. We don't talk about them for another couple sections, but it's gonna make this proof 10,000 times easier. Do you remember doing this? Let me see. I told you, if you have two lines that cross, they're gonna cross at a point, right? Yeah. And then let's say we have these angles, 1, 2, 3, and 4. I have no idea what this angle is, right? Let's call it X. What would angle 2 have to be?
181.
Yes, right? Because don't angles 1 and 2 add up to 180? They make that straight line together. So this one has to be 180 minus X. You agree? We had a homework problem that was like this way back when. What does angle 3 have to be? X. Because you're going to do 180 minus this whole thing. And when you simplify that, you just get X. So look at angles 1 and 3. Aren't they equal to each other? And then wouldn't angle 4 also be 180 minus X? Do you remember what I told you those angles are called that are like right across from each other like that? You remember? Oh, you're close, but no. Julia? They were called vertical angles. And remember I said it has nothing to do with a vertical line. It just, I don't know why we use the same word to mean, in math, we use it to mean so many different things. So when you have two lines that cross, the angles right across from each other are always going to be equal, no matter what their measures are. They're called vertical angles. So we will officially put this in your notes soon, but we can use it now because we know, we just proved that it's always true. So look what we get to say. And you can use this now forever. Doesn't this mean, look at angles 2 and 3, aren't they right across from each other? Sorry, if you're looking at your diagram. Yeah, angles 2 and 3 have to be the same. So I'm going to say angle 2 is equal to angle 3. And couldn't I say the same thing about angles 1 and 4? They're right across from each other too. So I'll combine these into one step here. And my reason, I just get to say vertical angles. Yes. Now check this out. I wonder if you can follow my logic here. I'm ready to now say angle 3 is equal to angle 4. How? Using just the steps we have. Sam?
Because angle 1 is equal to angle 2.
Yep.
Since angle 2 is equal to angle 3.
Exactly. This is transitive. Oh, I should let you say it. But yes, this is transitive. Check this out. See this line right here that says 1 is equal to 4? This line right here. 1 is equal to 4. Instead of writing 1, I could have written 2. And then instead of writing 2, I could have written 3. And that's exactly what I did. See how I substituted twice? I did 2 of them in one step. That's transitive. If you had put substitution for this again, it is substitution, you just did it twice. So if it's more than once, we just go with transitive. Oh my gosh. You could have proved this without vertical angles, but you would have just proved vertical angles in it anyway, and it would have made it like 10 more steps. So might as well just cut right to the chase. Okay, you guys. Are we liking proofs a little bit more? Oh gosh, just a smidge more. Oh, is anybody liking them a smidge more? Okay.
Because I didn't get the title.
Okay, good. So let's see, you guys say 11:05-ish?
Oh, yeah.
Why don't we do, let me do that. Let's just finish proof practice 1. So just numbers 1, 4, and 5. Those 3 that we haven't done yet. That's it. Yeah.
For homework.
Yes.
So I took number 1, I did most of it, but I don't know how to read these ones.
And actually, guys, I'm gonna cut this down even further. Don't do 5, just do 1 and 4. That's it, just 1 and 4, yeah. But maybe you can finish the 4 classes over. Let's see. One, so step two, we gotta go back. If you have. You guys see what I'm gonna do, take your top line, LM is equal to RN, and you're gonna subtract this from this line. That would be subtracted, so if you did LM minus XM on one side, on the other side was RN minus XM, that's subtraction. You had one thing that was just now you're subtracting the same thing from both sides. Same thing with me. But then you wouldn't have it equal to LX.
Yeah.
You know what I mean? These two things, I think you're combining multiple steps in one. So you should have this same top line, but now you're just gonna subtract this from this side and subtract this from this side. So, and that's it for line two. Have the ln minus xm equals pn minus xm. That's subtraction, yes. Okay, that you can do. And now let's see where to go from here. So set xm. That's part. I actually wonder if now so line two, that's right, but I don't know if that's actually gonna help us. I might do- Yeah, you know what, I'm gonna change, it's a correct step, but it's not the correct one to get us to where we want to go. We would want- Why don't I guys help you guys set up number one together? I feel like you're gonna be stuck. All right. Check this out, everybody. So we have the whole thing is equal to the whole thing. I also know that this piece is equal to this piece, and I want to just get LX equal to XP, right? Let's do this. Isn't it true that if I add LX plus XM together, don't I get LM?
Yes.
Okay, same thing on the other side. This plus this would equal the whole thing, right? Now, since I know the whole thing equals the whole thing, couldn't I then say this plus this equals this plus this? Because of substitution. And then, because I know this, I should just be able to subtract those parts away. Then I'd be left with exactly what I want. Let me see if I have enough time to write it down, but that's exactly what you would do. You've got LM congruent to PN and XM congruent to XN. Given. So another thing that I know is, okay, cool. Well, LX plus XM together, doesn't that get me LM? Doesn't that get me that whole thing? And I can say the same thing for the other one. NX plus XP equals the whole thing NP. Why? What would the reason be then? What says part of a segment plus another part equals the whole segment? Taylor. Yes, your braids are perfect. Did you do them yourself?
No.
Oh. Can you do them yourself? Do you want? Yeah, me neither. Not like that anyway. The side one I had yesterday, I did myself. That'd be funny if my husband did it for me. Anyway, segment addition. Okay, everybody, check this out. This is where it gets so cool. See how in my top line I had LM was equal to PN? Can't I just, instead of writing LM, Look, there's another LM, so couldn't I just write this piece instead? And then do the same thing, instead of writing PN, write what it's equal, or NP, whatever. Those are the same things, so we can just write this piece. So you get to say this, LX plus XM equals NX plus XP. Do you see how I did that, swapperoo? What would my reason be? I did substitution. Look at my end goal. Look at the end goal. I just want to get LX equal to PX or XP, whatever. I'm so close. I just have to get rid of this thing. Can I? Yes, look right here. You already said that they're equal to each other. So I can just subtract them away. They're gone, just like that. I get to what I want. LX is congruent to PX. Yes. What's my reason? Subtraction. By the way, I'm all for abbreviating, but you can't abbreviate substitution and subtraction. They both be sub, right? You need at least a couple letters past it. Otherwise, I wouldn't know which one. I guess just number 4, yeah. So that's all I need to see. Angle, or number 4 on the top. Give it your best shot.
That's supposed to be substitution. I'm not sure if it would work because that's
Let me look at the. See here. All right. So can you say DE is equal to EF, AB is equal to BC? Yes, but that's not why. So how did you know that? How did you know that this is equal to this? That's it. Definition.
No, it's actually.
Yeah. Definitions, theorems, postulates. Yes. All right. And then where'd you go? Then you said EF is equal to BC. How do you know that?
Oh, like the muff?
Transitive.
Yeah.
So the problem is, if you have, so you're saying EF is equal to BC, right? So I'm gonna try and follow the line. So here is EF is equal to DE, but you don't have D, oh, okay, DE is equal, oh, right. You can say it. You're totally right. I was about to say you were wrong, but you weren't. So that's how I check it. So I say, all right, she's starting with EF. So then I literally follow it in your stuff and see if I can get to where you ended up. And you did, so it's fine. Yep. Yep, EF. And I eventually get back to BC. It's perfect. You're welcome. Yeah. So if you, so you don't want line 2?
I was just wondering if you could already
So if you don't have this line, if you try to subtract XM from this and subtract XM. It wouldn't land you here, though. You'd want to go right to here?
No.
Oh.
Because just those two. So would you have to send those two right over like?
Yeah, because I don't think you could say line 3 without this.
Okay.
Because if you just subtract it from both sides. So you get a step that says LM minus this equals PN minus that. I don't think it's gonna ever land you here without going through that step. Yeah, I don't see a way to skip it. There might be another way to do it, but you'd still need something that showed that the two end together. Have a good weekend.